Hi, Common Core Algebra 2, Notes for Video, 4.10 Logarithm Laws. So logarithms have very much the same types of laws that exponents do because logarithms are exponents. So if we take a look at some of these laws, and if you look right here at product, we know, so exponent version, we know if we have the same base, that you keep the base and then you add the exponents, all right? So that's kind of hard to see, so let's get rid of that. So you have b to the x times b to the y equals b to the x plus y. And very similarly in logarithms, if you have log base b of x times y, basically what that means is that you can add the exponents. So it's log base b of x plus log base b of y. All right, quotient, same thing. You have the same base, you subtract the exponents. So here, I'm looking right here, if we look at log base b of x over y, that's going to be log base b of x minus log base b of y. And the last one is the power law, which tells me if I have b to the x raised to the y is b to the xy. So that's log base b of x to the y is equal to y times log base b of x. So taking a minute and understanding these laws really will be helpful before we start moving on. So take a minute, look at them, make sense of them, and meet me at exercise 1. So which of the following is equal to log base 3 of 9x? So if we use our laws, well, I know I have multiplication here. So that means I'm going to have log base 3 of 9 plus log base 3 of x. All right? Now, log base 3 of 9, you can evaluate that. Remember our loop, that means 3 to the what power is equal to 9. So the answer here is 2 plus log base 3 of x, which we can't evaluate because we do not know what x is. So right here, number 3, is my answer. Looking at exercise 2, the expression log x squared over 1,000 can be written in equivalent form as, well, I'm not even looking at the answers right now, but I know I have division here. So I know I'm going to have log of x squared minus log of 1,000. And I can rewrite this one more time using my product law as 2 log x minus, now log of 1,000, there's nothing here, this is a common log. So this means 10, right, to what power gives me 1,000? And the answer is 3. So I look here, and I do have that answer. It's right here at number 1. Looking at exercise 3, if A equals log 3 and B equals log 2, then which of the following correctly expresses the value of log 12 in terms of A and B? So log 12 is equal to, now you've got to put this in terms of our A and B. So that's the same thing as log times 4 times 3. That's the first thing that comes to my mind, but I don't have the log of 4 here. I do have the log of 2. So this is the same thing as the log of 2 times 2 times 3. Now remember, in multiplication, I simply add them now. So it's log 2 plus log 2 plus log 3. And those I do have represented as A's and B's. So I have B plus A, which is 2B plus A. So do we have that here somewhere? We sure do, right here in number 4. Commutative property says that we can flip them around to A plus 2B. So looking at exercise 4, I'm going to slide up a little bit to give myself some more room. So what is this mess going to be? Well, the first thing is log base 2, and I'm going to do some rewriting here. Let's call this x to the 1/2 divided by y to the fifth. And I even like rewrite how the fraction looks so it makes more sense to me. So I know this is the same, this is division, so it means subtraction. So log base 2 of x to the 1/2 minus log base 2 of y to the fifth. Now I have to apply my power law, which means I'm going to multiply that 1/2 out front. So 1/2 log base 2 of x minus, and the same thing goes for this one. I'm going to pull that 5 out front, my power, 5 log base 2 of y. Now I can't simplify this anymore, so is this here somewhere? It sure is, right here in number 3. All right? So that's the end of day 1. I'm going to actually just put something here that says end of day 1. Because I think we need to practice this before we move on. All right, so tomorrow in class, we are going to look at the first part of our classwork. You're going to do some practicing, and then we're going to continue with this lesson tomorrow. Now, if you happen to have time right now and you would like to continue watching this video for the second day, feel free to, so your homework is done. Okay, so I will see you tomorrow, or I'll see you in a few minutes. Okay, so on the second day, we're picking up here at exercise 5, the value of log base 3 of root 5 over 27. Now this is sort of the same thing we've been doing, but I wanted to give you some extra time to practice these before we started getting into some of the more complicated questions. So what does this mean? Again, I'm going to spend some time and rewrite log 3, and this is the same thing as 5 to the 1/2 divided by 27. Now the beautiful thing about this thing is you can put this right into your calculator, but our answer choices do not give us a value. So we have to make sure that we are just simplifying this. So because we have division, we know that's subtraction. So log base 3 of 5 to the 1/2, all right, minus log base 3 of 27. So this is going to be, and I'm kind of going into my other problem, 1/2 log base 3 of 5 minus log base 3 of 27. And if I look at my answers, my log base 3 of 5 is here. So that's here, but my log base 27 is not. So this is what we're going to switch. We're going to say 3 to what power is 27, and the answer here is 3. So it's 1/2 log base 3 of 5 take away 3, and that is not here. But because I have this 1/2 out front, I can multiply this through, or I can divide this whole thing through by 2, and I can get, so this is going to be the same thing as, if you want to do the whole thing, it's log base 3 of 5 minus 6 all over 2. All right, so if we do the division here, you'll see you get 1/2 log base 3 of 5 minus 3. So the correct answer here is number 1. So why don't you write down what you need to on that one, because I'm going to erase it before I start exercise 6. So in exercise 6, we have log of x and log of g of x. Okay, I'm sorry. F of x is log of x. G of x is 100x cubed. All right, so f of g of x means we're taking g of x and we're putting it into f of x. So that means we do log of 100x cubed. And here we simply have to simplify it. So this becomes log 100 plus log of x cubed. And of course, if there's no base, we know the base has to be 10. So log of 100 is 10 to what power is equal to 100? And of course, the answer is 2 plus 3 log x using our power rule, the third rule. All right, so 3 log of x. So if we take a look here, 2 plus 3 log of x is right here at number 4. So write down what you need to. I'm going to erase this one before I move on to 7. Okay, exercise 7. The logarithmic expression log base 2 of radical 32 x to the 7th can be rewritten. All right, so now we're getting a little bit complicated here. So let's see what this is. So we're going to rewrite things first. So we have log base 2 of 32 x to the 7th raised to the 1/2. So I can use the power rule first, right? And I can say 1/2 log base 2 of 32 x to the 7th. Slide up a little bit. We get to 8. If log base 7 is k, and log of 4900, then log of 4900 can be written in terms of k, which means we have to put it in terms of log 7. So think about what that means. That means we're going to have, let's see, log 4900 would be 7 times 700, right? Which is 7 times 100. Okay, so this is going to be log of 7 times 7 times 100. So what I'm really doing here is I'm kind of just thinking out loud as I'm doing this because I'm pulling it into forms of log 7. And now because this is base 10, I can find the log base 10 of 100. So this is equal to log of 7 plus log of 7 plus log 100. Right, common logs. So log 7 we said is k. So this is k plus, and the log of 100 means 10 to the what power is 100, and the answer is 2. So we have 2k plus 2, but you can see that's not here. So don't think that this is the answer because it's not. This is definitely not it. This is not it. And if I distribute this, voila, I get the right answer. So notice how those answers are sometimes not in the exact form. You have to manipulate them a little bit. So be wary of that. Okay, exercise 9. Okay, mine is messed up a little bit. It's over here. So exercise 9 says consider the expression log base 2 of 8 to the x. Use the third logarithm law, which is the product law, to rewrite this as an equivalent product and simplify. So I know that if I have log base 2 of 8 to the x, we get x log base 2 of 8. And it says, and simplify. Well, I know that log base 2 of 8 is equal to, right, 2 to the what power is equal to 8? 2 times 2 is 4 times 2 is 8, so this is going to be 3x. So that's what I'm simplifying it to. B says, test the equivalency of these two expressions for 0, 1, and 2. So I think you can probably do that on your own. I don't think you need my help to do that. And moving on to C, just going to slide up a little bit. Show that log base 2 8x is equal to 3x by rewriting 8 as 2 to the third. Oh, we already did that, so we don't even need to do that part. So we kind of incorporated A and C together, which we're okay with. All right, and that's the end of day 2. This was not a very long process, but because this is a little bit tricky, I wanted to give you 2 days to work on it. So make sure that you really understand what we did today, not just writing things down. All right, really go over it again. Look at some of those examples one more time before you come into class tomorrow so you're really prepared for the classwork. Okay, until tomorrow, make good choices and we'll see you then. Bye-bye.